Okay, ladies and gentlemen, this is another question. That is question 2. The electric field intensity at a point situated 4 meters from a point charge is 200 Newton per coulomb. If the distance is reduced to 2 meters, the field intensity will be A, 400 Newton per coulomb, B, 600 Newton per coulomb, C, 800 Newton per coulomb, and D, 120 Newton per coulomb. So ladies and gentlemen, this is electric field intensity, and if you will remember when we said electric field intensity, it is represented with capital letter E. It is represented with capital letter E. That is electric field intensity. And this electric field intensity is the something as F all over Q, which at the end it will give us electric field intensity is equal to KQ all over R square. So we by looking at, of course, this question, we are given first, at the first stage, we are given E is equal to 200 Newton per coulomb. Then we have the distance R is equal to 4 meter. And then the distance is reduced to 2 meters. So let's now, from here, let's calculate KQ. Because we don't have K here, we don't have Q, although K is constant. And so what I want us to do here, ladies and gentlemen, let's calculate KQ. So since from here we have E, look at it, we have E as 200. So we can now say we have 200 here as a Newton per coulomb. And then we have KQ divided by the R is 4 meter. So here, therefore, we have 4 meter square. So therefore, we can make now KQ subject of the formula. So therefore, KQ now is equal to 200 times 16. So if you now multiply 200 times 16, this will give us 3,200. This will give us 3,200, 3,200 Newton meter square per coulomb. So we now have KQ. So what are we going to do? So we are now going to calculate electric field intensity when the distance is reduced to 2 meters. So I think it's simple, ladies and gentlemen. From here, we can see that, of course, E from here is KQ all over R square. So we already have KQ as this. So we now have E is equal to, because this is what we are looking for. We are calculating electric field intensity when the distance reaches to 2 meters. So therefore, the KQ is 3,200 divided by the distance is 2 meters. So therefore, we have 2 meters, then we square it. And then this will give us 3,200 divided by 4. Then 3,200 divided by 4, this will of course give us 800. So we now have 800 Newton per coulomb. So this is actually the answer to this question too. So please, ladies and gentlemen, don't forget and keep following me, subscribe and join to my YouTube community. So the answer is option C. So let's move to another question.